Hello, it's Carly McAvoy. I have one more set of problems I want to show you about rational expressions, adding and subtracting. We're going to call this part 2. Again, we want to add and subtract things that have different denominators. So we want to find the LCD. The LCD is going to represent both of these. This standalone y is very different than the y plus 2. Let's say that this turned out to be 5, this would be 7. Those are just two distinctly different numbers. So all I can do to find the LCD is multiply those together. So my new denominator is going to be y in y plus 2. That's my LCD. Then I go back and say, well, what is this fraction missing out of here? And it's obviously missing that standalone y. So I would have to multiply that by y, which means I'm going to have to do the same thing to the top, and that's going to give me 5y. And then we're saying, well, what is the second one missing? Well, the second one had the standalone y, but it doesn't have the y plus 2. And so I need to multiply that times y plus 2. That's negative 3 times y, negative 3y, and negative 3 times 2, negative 6. So now when I combine those, 5 minus 3 is 2y minus 6, and y plus 2. I always want to simplify if possible. If you're not sure, when in doubt, factor it out. That's my rule for you. Take the 2 out, that leaves y minus 3, and you have y and y plus 2. So it turns out that either one of these would be acceptable because they're even though this one is fully factored and the other one's not, but there's nothing that can be canceled. Always simplify if possible. When in doubt, factor it out. Okay, whoops, I didn't tear this one off. All right, so let's take a look at the next one. This has 3 parts, 3x plus 9 over x plus 4, 4 over x, 12 over x squared plus 4x. So in order to find the LCD, I need to factor that last term, and it turns out when we factor that, we're going to see that it actually contains what the other two fractions had in there. So our LCD has to represent all of this. I need an x plus 4, so I'm going to rewrite it over here. I need an x plus 4. I need a standalone x. I need a standalone x, which I already have. I need an x plus 4, which I already have. So my LCD is x and x plus 4. Then you have to ask yourself, what was this fraction missing out of this? Well, it had the x plus 4, but it was missing the x, so I have to multiply this by x. So I have x times 3x plus 9. What about that second fraction? Well, the second fraction had the standalone x but was missing the x plus 4, so I have to multiply the 4 times x plus 4. And what about the last one? Well, it had the x and the x plus 4, so I don't multiply it by anything. It wasn't missing anything, and that's how I get the minus 12. Now I want to simplify all that out. I have x times 3x, which is 3x squared. I have x times 9, 9x, 4x, 16, minus 12. I'm just going to write LCD under there. I don't want to forget about it, but I don't want to write it out right now. And then I'm going to combine all that. I have 3x squared. I have 9x and 4x, which is 13x. And then I have plus 4. And it looks like I could maybe factor that, so I'm going to have to try. The LCD is x and x plus 4. I'm going to come over here and factor that, 3x and x, and I'm going to put 4 and 1. It's all pluses. Would that be it? 3x squared, 12x plus 1 is 13x plus 4, yep. And then I have x over x plus 4. So I found the LCD, I changed all the fractions, I combined it up, and now I'm going to have to simplify and cancel, so I'm doing that. So I end up with 3x plus 1 over x as my final answer. Notice all the things I had to go through to get to that final answer. I never dropped my denominator, even though I was able to cancel some at the end. That follows along. Okay. The last one I have here is a subtraction problem with different denominators. So I'm going to start off by factoring. I have b, and then I have b minus 5 and b plus 2, and 4, b minus 5 and b plus 7. Again, do some factoring off to the side if you need to. You don't have to be able to do it all in one step, all at once. But my common denominator, I have b minus 5. And here's kind of how I suggest. Look at this one. I have b minus 5, so I need that. I have a b plus 2, so I need that. I have a b minus 5, which I already have. And I have a b plus 7, which I don't have, so I'm going to have to add that. Now that I have all that, now I'm going to go back and say, what is each fraction missing? This one is missing the b plus 7, so I'm going to have to multiply that times b plus 7. If I was to put it in the denominator, I'd have to put it in the numerator as well. So I have b and b plus 7. This one is missing the b plus 2. If I was to add b plus 2 into the denominator, I'd have to add b plus 2 here. And that would give me then 4 times b plus 2. So I've rewritten my numerators based on what was missing out of each fraction, and now I need to simplify those. So I have b squared plus 7b minus 4b minus 2. Don't forget about, or minus 8, sorry, as I said that, don't forget about distributing your minus 4 to the 2. And then I still have my LCD, which I'm just going to write LCD for a minute. And then I have b squared, 7 minus 4 is 3, minus 8. And I know that 8's never going to get me to 3. 8 and 1, 2 and 4, there's no way to simplify that, but I would if I could, as I have in the other ones. But this one is not going to simplify. But notice that when I'm adding expressions, my final answer has the denominator in it. So people say, well, sometimes you can get rid of the denominator. If you're solving an equation, that's true. But think about just your basic fractions. If you were to solve this one, you'd multiply and get a common denominator of 6. And you would multiply the first one by 3 and the second one by 2, and you would get 5/6. You wouldn't say then, oh, can't I just say that answer is 5? Well, is 1/2 and 1/3 5? No, it's 5/6. I can't just throw that denominator away. And this is just another fraction problem. You have to follow the same rules, that we have to have that denominator in there. All right, have a fantastic day. We'll talk to you next time.